Thanks everyone for joining the session. Excited to be here and excited to be sharing uh, the topic here. The topic of discussion that we want to present here is the benefits of Compute Express Link for high performance computing. To begin with, let's start by looking at the industry landscape. If we look at the megatrends in compute industry, it includes cloud computing. A significant growth is what we've seen in AI and analytics, as well as increase in demand for computing capabilities in network cloudification, which would be in forms of technologies such as storage-defined networking, network function virtualization, mobile edge computing, so on and so forth. Another interesting area of application that is growing at a very fast rate is high performance computing. And that is done by centralizing and virtualizing networks into data centers. I do have some slides that describes what HPC does and how CXL benefits HPC. So we'll talk more about it in the next few slides. The bottom line here is in all these areas, there is an inherent need to develop architectures and protocols that enables these megatrends. And if we were to enable meeting those needs and help with the evolution of these applications, what we need to look at is interconnects that meet the computing and capacity requirements. And that's really where CXL comes into play. A quick recap of CXL here. What are the challenges CXL tries to solve, and how does it manage to solve them? I described the industry landscape in the previous slide and the applications that the storage industry is evolving towards. And some of the challenges that the industry has been grappling with would be meeting the data processing and high performance demands for data centers. Applications such as HPC, AI, and ML is in need of disaggregated and heterogeneous computing environment. And that's because wherever there is a need to increase the memory bandwidth and performance efficiency, you do need disaggregated and heterogeneous computing. What I'm trying to say here is that there is a need for interconnect that is standardized, but at the same time has the flexibility built into it to support memory, storage, or even devices such as accelerators. And that's exactly what CXL was designed to do. Designed to address these needs by providing an open standard coherent interface leveraging already known ubiquitous PCIe electrical interface, and at the same time has the added benefit of supporting additional protocols for supporting memory and caching devices. It was designed to provide a low latency path for devices that are cache and memory bandwidth oriented. Also, it has asymmetrical host managed architecture, which eases the burden of cache coherent interface designs. Bottom line here is CXL provides a very powerful set of features with which we can solve the challenges in computing industry that I outlined before, and we can build and evolve a system architecture for future based on this protocol. Before we into the main topic of discussion, let's quickly look at some of the recent developments with CXL Consortium. As many of you might be aware, the industry was looking into Gen Z protocol in parallel to CXL to solving some of the problems that I outlined before. And recently, CXL and Gen Z forums have joined hands to continue development in the same direction of a memory coherent interface. In fact, an agreement between CXL and Gen Z consortium has been signed, and once the Gen Z asset transfers are completed, Gen Z will finalize its operations. So what does that all mean for Open Fabric Alliance Forum here? That means that as far as the OFA Forum is concerned, all the OFA efforts will be focused on CXL and no diversion towards Gen Z. In fact, the working group has already begun modeling applications based on one of the CXL 2.0 core features, which I'll talk about in the next few slides, which is memory pooling and memory sharing. And this is expected to evolve to include CXL 3.0 fabrics as well. In future, libfabrics is expected to add support for CXL fabric, and the CXL consortium is open to any collaboration opportunities on this front. Now, jumping into the main topic of discussion, which is how does CXL 2.0 standard help HPC applications? At a high level, uh, high performance computing has transformed industries from finance, genomics, autonomous driving, seismic imaging, you name it. It all requires high performance computing in today's world. So it's not surprising that the demand for these computing resources continues to rise as organizations of all sizes are really striving to keep pace with innovation in the marketplace. If one needs to stay competitive in this dynamic environment, then enterprises really need to turn to cloud-based HPC solutions so that they can drive towards greater return on investment. The diagram here shows at a high level what are the components involved in an HPC system. In HPC, what we have is a combination of computing nodes that you see here, which includes processors, disks, operating systems, memory, which are all grouped as clusters of nodes. And what these individual compute nodes, whether it's compute node 1 or compute node 2 that you see here, can be specialized components such as GPUs, NICs, and accelerators, or it could be a generic compute node with just CPUs. These compute nodes then interconnect to the storage media that you see on the right-hand side here, as well as a head node, which is what the user uses to access these nodes. So as evident, the advantage of architecture like this is that you have a disaggregated framework, and what we achieve by that, including which performs consuming of much faster rate, increased efficiency of resources. And the thing I mentioned, efficiency of resources is key because you're actually improving the efficiency of resource entire topology. Efficiency has been uh, uh, pretty low and HPC applications, and one area where we really can improve. Uh, so this is all industries that I've outlined is climate modeling and data analysis. So the question then, where does CXL play a role in architecture? We want to note compute capabilities in these compute nodes is faster data processing in a heterogeneous drives the for greater memory capacity and bandwidth. And this, so what I'm going to do is going to help aggregate development and a high-level protocol. CXL protocol defines 3 types of protocols based on the kind of device attached to the interface. Let's start the hand corner, which is showing type 1 protocol. A typical type 1 device would be an accelerator that has cache on the device, but no host managed device memory. A type 1 device can allocate and make use of the coherent host memory with frequently used data cache on the local cache. An example of that would be a smart network interface card. In the center, you see type 2 device and protocol. Type 2 supports all 3 protocols. .io, in fact, is the PCIe protocol that we are all familiar with. An example of type 2 device would be an accelerator that has cache on it, as well as high bandwidth memory attached to it, which is visible to the host. And the idea behind this would be that the accelerator can use this memory for computation. One example of a type 2 device would be high performance GPU. Type 3 device would be memory buffers that has memory device attached to it, and this memory can be used as a coherent system memory to meet the bandwidth and capacity requirement of the host processor. Another interesting thing to note here is that CXL offers flexibility in the type of memory you can attach here. So the attached memory can be DRAM or persistent memory, for example. Quick recap of the benefits CXL. It primarily fills the gap between the faster DRAM memory and the slower traditional storage memory that you see here at the bottom, which includes SSDs and HDDs. It moves persistent memory from the controller to CXL and provides a standardized management of memory and interface, as well as provides support for a wide range of form factors. This is a good diagram that shows a high-level view and scope of CXL application and where CXL 2.0 adds benefit compared to CXL 1.1. 1.1 was focused on single node architecture, and it was geared towards achieving PCIe and CPU to CPU coherency. This diagram explains what CXL 2.0 feature actually helps in an interconnect topology like this. So if I break this diagram down, we see three pieces here. The top layer is the wireless interconnect, and that interfaces with the middle layer, which includes a spine leaf architecture, which is a typical data center interconnect with a number of nodes in form of racks that you see here. And then there is a processor interconnect at the bottom. What we're focusing on, you see a number of racks. Where CXL 2.0 today within the interconnect, CXL will provide a coherent interconnect between nodes as well as within a given rack. Imagine being able to pool different devices such as accelerators, memory devices within this rack. And that rack scale can be expanded out significantly in a scenario like that. I have a slide coming up that describes the pooling concept, but at a high level within this rack, what you can do with CXL 2.0 is having a memory pool, in other words, pool of devices or pool of memory that can be attached to a CXL switch, and that pool can be shared between different hosts connected to the switch. 2.0 also defines single logical devices and multiple logical devices, which I will explain in the next slide here. As I mentioned in the previous slide, CXL 2.0 has support for single level switching for memory pooling feature, which is quite useful for heterogeneous applications such as HPC. From the diagrams here, you can see that CXL 2.0 supports switching to enable memory pooling, which I just described. With the CXL 2.0 switch, a host can access one or more devices from a pool of devices. As an example, on the diagram on the left, you have a number of single logical devices forming a memory pool behind the switch, which can be assigned to different hosts dynamically. One thing to note here is that although the host must be CXL 2.0 enabled to leverage this capability, the devices that are connected behind the switch can be a mix of CXL 1.0, 1.1, and CXL 2.0 enabled hardware. Also shown on the right-hand side here is a 2.0 multi-level device. 2.0 defines MLDs, multiple logical devices, which can be partitioned as sub-blocks, allowing up to 16 hosts to simultaneously access different portions of the memory. For example, device D2 here is an MLD, and some logical subcomponents are assigned to host H1, and other logical portion of that MLD would be assigned to host H3 here that you can see. Extending on the slide, another key feature of CXL 2.0 is not only do you have the ability to have a single switch, but also have the ability to cascade a number of switches, which can help in expansion of memory as well as the kind of devices that you want to expand it out to. And that's what we are showing here on the right-hand side. In a topology like this, one key attribute that customers are extremely interested in, particularly when it comes to memory, is the RAS capabilities. Reliability, availability, and serviceability requirements are increasingly important in data centers and HPC applications. Reliability would be the ability to prevent or correct errors. Availability would be the uptime of the equipment, meaning that the ability of the equipment to recover from errors, and then serviceability would be the ease with which system administrators can diagnose the problems. 2.0 has a number of RAS features, which includes all these features that I'm showing here in the table. I'm not going to go into every single line item, but at a high level, it includes support for poison, viral, memory logging, and hot plug, which are some of the key attributes needed for ensuring that the attached memory is reliable and easily serviceable. Another important factor for a disaggregated topology is data integrity. And to that end, CXL provides integrity and data encryption, CXL IDE, which defines the mechanisms for providing integrity and protection for data that traverses the CXL link. And this is actually defined for all three protocols that I mentioned here, .io, .mem, and .cache. And the cryptographic schemes are aligned with the current industry best practices and has IDE key management features defined. One advantage we have in the industry is there is also already defined transport protocols such as MCTP, which can be done through SMBus or PCIe VDM, as you can see from the block diagram on the right-hand corner. But also we have data modeling protocol in SPDM. So CXL leverages that and builds on these layers and provides a more robust data integrity framework. What I mean by that is this would have the ability to send requests by the host software to an IDE capable component. The request can provision IDE keys and instruct the components to initiate or tear down CXL IDE. Requests and responses are going to be confidential, and it will have integrity protection built into it. And all this is built by leveraging existing industry standards, as I mentioned before, and that gives quite a bit of advantage to build on top of what already is present in the industry. Whether it's root complex, switch, device, or any of the components involved in the topology, CXL 2.0 provides integrity and data encryption of traffic across all entities for all protocols, as I mentioned before, which is the .mem or .memory traffic, .cache, or .io. And those are the areas of protection that's actually covered within the spec itself. So that is what's covered in CXL 2.0, and building on that, CXL 3.0 would have additional capabilities to enhance some of the fabric features. Memory pooling will include devices such as global fabric attached memory, which would be a new family of memory devices. From single level switching of 2.0, 3.0 will expand multi-level switching to accommodate larger fabrics with spine leaf topologies. And this will be combined with some new symmetric coherency capabilities, as well as better software and fabric management features. And all this will be backwards compatible, meaning that you can have a CXL 1.0, 1.1, and 2.0 device attached to a CXL 3.0 device. And that specification is actually in works and will be available pretty soon here in the next quarter or so. Last but not least, in summary, there is a significant momentum within the industry for CXL, and the consortium continues to grow. We already have 180 plus members, and it's continuing to grow, as I mentioned. The idea here is to respond to the industry needs and challenges, and hence, as a next step towards that, developing and establishing an MOU with OFA to extend fabrics is something that the CXL consortium is working on. 2.0, as I mentioned, uses new features and usage models that immensely benefit HPC applications, and that includes switching, pooling, persistent memory support, as well as security features, and it is going to be backwards compatible. So I would encourage anyone listening here to consider joining the CXL consortium. There is a lot of work to be done, and there is a lot of momentum in the industry, and it's a lot of exciting work to which we can all contribute towards. So if you have more interest in learning about what kind of work is being done in CXL, please visit the website here. And there is also the links for the social media handles here. That was the last slide. Thank you for giving me an opportunity to speak here. Any questions?
So thank you, Sandeep. I really enjoyed the presentation, and I'd just like to say we've really appreciated the collaboration in the Open Fabrics Management Framework work group with the CXL folks. So thank you for that. We do have a question. Are there any protections for CXL 1.1?
No, the security features for 1.1 is terse. I don't have a list of features that were actually included in 1.1, but I can look that up and send that information over. But 2.0 is where the IDE was actually more well defined and all the different layers were added.
And you say the next revision of the specifications should be available in about a quarter?
Yeah, actually, it should be completed pretty soon in the next few weeks here. Most of the work on CXL 3.0 is complete, just finalizing on a few details, and I believe it's going through some review cycles.
Okay. Are there any other questions from anyone online? Anyone want to type something into the chat? What are the one question here? What is the criteria for joining the CXL consortium?
I don't think there is any set criteria. I think you can just register on the CXL forum, and yeah, you should be set to go.
Cool. Okay, thank you very much. I don't have any other questions queued up. So thank you very much for that presentation and update.
Yeah, thanks for the opportunity to present exciting things here, and I look forward to talking more in this forum in future.
Cool. Thanks again. Okay, and that wraps it up.